there are two ways to get propane to an engine. You can do it as a liquid, or you can do it as a vapor. And traditionally, what you see across the world is a vapor injection system. Efficient, inexpensive, proven, well proven. We brought something to the market a little different, which is a liquid injection system, and I'll talk some about it. And I will get down the weeds for a few minutes, but if you want to get down the weeds with me, it will be just fine. Basically, though, any of these engine systems we talk about, for us to meet what EPA wants us to do, and California Air Resources Board, or Texas Railroad Commission, or anybody, these are highly engineered systems. These aren't kits from a backyard mechanic. If you brought anything that has a motor, from a go-kart to, I guess, a space shuttle, and brought it to our shop, probably anybody else's shop, we can make it run on propane. Propane has enough characteristics that's similar to gasoline. We can make anything that's an internal combustion engine, we can make it run on propane. The challenge is to make it run on propane such that CARB likes it, EPA likes it, it's OEM quality. And that's the challenge for all of us. These systems basically have three components, if you will. What we do with the engine around the fuel rail, a propane tank or tanks, and again, we don't really talk much about storage. Again, if you're used to talking about natural gas, one of the first questions I usually hear asked is, well, what about range? And the answer probably is 40 miles or 30 miles or 60 miles if you got a tractor trailer maybe, and you have a big space for tanks. For propane, we don't really worry about range. We are used to, as a standard, if you have a gasoline vehicle that's used to having a range of 200 miles, well, we generally shoot for 200 miles. But as a rule, our propane tanks, we personally don't design much that wouldn't have a range of less than 250 miles. And you'll see, here's a dual tank application, but we have a lot of applications that are 3 tanks or 4 tanks and can be pretty specialized as well. The other component is just what goes inside that fuel tank, and that's a little bit different. In a vapor system, we take the tank pressure, and on a day like today, a propane tank would have a pressure of about 200 psi, so it's not very hard to get vapor up to the engine. In a liquid system, we actually pump it just like the fuel pump you're used to in a gasoline system up to the engine. And as we kind of move through the development of this, and you see more like the Ford Taurus, which has a, I guess they would call it EcoBoost, but it's really nothing more than a direct injection engine, that you're going to see that engines are changing in a way that makes them much more susceptible to being converted to run on propane. It actually makes it much easier for an engineer to get propane into the same injectors that the gasoline is using. And what that does for us is it not only makes it simpler, hopefully it makes it cheaper, and it's very efficient as well. We won't beat this around, but why would you go to all this trouble to run propane? Well, I guess you do it for one of 3 reasons. One, you want to save money. That's what most of us talk about. While we can wear a green badge and talk all about emissions, and we can talk all about reducing energy or increasing our energy independence, reducing foreign oil, at the end of the day, it really gets down to money. I'll just let you study that for a second. We certainly win the prize for reducing CO, CO2, hydrocarbons, NOx, and we take pretty good pride in the fact that when the diesel standards came out for 2010, the engines that we were certifying in 2007 already meet those standards. In fact, beat them significantly. You talk to many diesel engineers, they won't talk. They want to tell you what kind of struggles they went through to meet the 2010 criteria. Propane was meeting it in 2007. Because I think the liquid injection system, it certainly takes away any concerns about fuel quality. Even though propane and gasoline have a little different BTU content, a gallon of gasoline has a higher energy value than a gallon of propane, we've just about negated that fact with efficiency, so it's pretty neat to see that happen. When we work historically very closely with General Motors. We're using General Motors controllers. So when you have a problem, when something's not right, or you just want to go in and see what your engine is doing, you use the regular GM test equipment, you hook it up, and all the fault codes read the same as they would if you were running gasoline or anything else. This system has about 40,000, there are about 14 million vehicles running on propane in the world. And just kind of as a sidebar, I guess if you went back and looked at data maybe 6 or 7 years ago, I think the data would suggest that there were 7 to 8 million vehicles running on propane in the world. So over the last 4 or 5 years, the world has essentially doubled the propane vehicle use, where in America, we've actually probably reduced to about 50,000 vehicles. And that's largely for two reasons. One, the complexities of EPA threw all of us a bit of a curve, and it took us about that long, frankly, to figure it out. And in a $2 gasoline environment, there's not a lot of economic incentive to change. But in a $3 gallon of gasoline environment, big economic incentive to change. And in a $2, and I saw prices coming in here. I noticed this morning, $2.60 is what I saw published on the street price here. We win that battle too, economics. If you're driving 15 to 20,000 miles a year and you have a substantial fleet, the economics are pretty well overwhelming for this. Again, we just talked about it. We use an injector. We use a Continental injector, but it's a gasoline quality injector. And again, you see the three components we talked about. Very simple. We put a tank somewhere, usually in the trunk if it's a car, or in the bed if it's a truck, underneath the bed if you prefer, because you want to put something in the bed of that truck. One of the things we do like about liquid, and we don't talk about it enough really, when you bring liquid to an engine, that's good for a lot of reasons. One is that liquid finally enters the cylinder. It of course flashes a vapor, and as it flashes a vapor, it cools. When it cools, that gas-air mix gets much more dense than normal, and it creates a much better combustion path than you would have expected if you had just a regular hot liquid coming into it. And then the second thing that cooling effect does is it provides quite a bit of protection for the engine components itself. Now GM and Ford and most of the OEMs have what they'll call a gaseous prepped engine. And there's no question but that propane is an easier fuel on the engine than, say, even ethanol. But the fact that we get a gaseous prepped engine, again, gives us strong confidence that if you want an engine that's going to go 250 or 300,000 miles without having any kind of head work or piston work, you have the tools in place to do it. The other thing we don't talk about, well, and I will just mention, for liquid injection, cold weather starting, it's kind of odd to talk about cold weather starting when it's 100 degrees outside, I guess, but cold weather starting is a true feature. We regularly see customers that will have good startability at -30 Fahrenheit. So that's a good thing. Hot weather starting, we have to do a few calibration tricks in the engine to get perfect hot weather starting, but the liquid injection into an engine gives us a lot of benefits, and we really like that technology. Again, we won't talk too much about a controller, but suffice it to say, if you take your vehicle to the shop that you normally take your vehicle, he'll plug his diagnostic tool in, and he'll read right on the fault codes what's the matter and going about fixing it. Don't really ever say it, but once you get over the initial cost, you save quite a bit in engine maintenance. I've been running propane vehicles almost all my life. We're used to seeing, we wouldn't consider changing our oil before 5,000 or 6,000 miles, even in severe city use. Rule of thumb for us was always double what we've been doing with gasoline engine. And at that time, really, if you push it and you started doing oil analysis, you'd see that you didn't need to change it then. Propane burns so much cleaner, which is one reason we get a cleaner tailpipe emission, and we talk about the environmental benefits. But that cleaner burning also translates into less carbon buildup around the pistons and the valves, and creates much better maintenance. I'll just say this, for us, most of our gasoline engines, we wouldn't think of doing look at the engine until it had been about 250,000 miles. And you don't see that very much on a traditional gasoline engine. Frankly, once we looked at it at 250,000 miles, we would often run them again another 100 to 150,000 miles before we did any work on them. So when you think about it, we don't talk enough about the life cycle cost. If you really look at the cost of the fuel, so your savings there, then you go back and look at the reduced oil maintenance and longer engine life, a big economic case to be made for switching over to propane. The other thing, if you're coming out of a diesel environment, I like to talk about quieter too. I never could figure out why companies like Aspen Tree Service, they go into a lot of neighborhoods at 6:30 and 7 in the morning, and what they found is they were more acceptable when they rolled in running an LPI-driven propane-powered vehicle rather than a putt diesel truck that was waking everybody up and making them crazy. The other thing we've seen in the school bus market, kids walking by that cowling twice a day, and the noise level between a diesel engine and a propane-fired engine is significant. And if you don't believe that, and you're in Texas long enough, walk around, you'll see a propane-powered school bus and go listen to it. It's pretty amazing. This is not, again, not a backyard mechanics. So we want to talk about safety compliance. You know, we're doing every single one of those standards. You have to do it if you're going to be playing in this ballpark today. These aren't one-off shade tree mechanic vehicles. These are engines that are set up to be sold in the thousands and meet all the federal criteria that you need to. Typical economics that I see in here, we picked, I think, pretty reasonable numbers. Gasoline at $2.60 and propane at $1.70. That's probably what you would find today. And I see that relationship almost over and over between propane and gasoline. Those numbers are pretty much what we see. About 14, actually saw some individual studies last week, and that customer was showing, on a lot of miles, he was showing 12.5 cents a mile of operation. It easily can be half of what gasoline is. We talked about it. I guess if you're a gearhead, I'll just mention propane has an octane rating of about 104. So sometimes people seem to be surprised at the performance. In fact, it's insulting to me because we have to sometimes give people a propane vehicle to drive to compare to their gasoline vehicle or diesel vehicle. And I'll just tell you, I've never seen anybody yet say, that doesn't drive as well as my gasoline vehicle. And it's obvious that we have a higher octane and it just has to be equal to or better performance. In fact, even in the diesel buses, we see a lot of people preferring a gasoline bus now for performance and torque, starting, and how it pulls a load. So it's a real compliment to us. We won't talk much about safety. If you want to talk about it, I think that's a great sidebar discussion. I think the industry's record stands for itself. We've been around a long time. We've got a long list of codes and standards that are monitored and improved and adjusted as technology adjusts. The tank, one of the things that Alliance has been so successful, really, I think, selling with police departments, not only because they drive a lot of miles, but they have some hellish wrecks. And a policeman has a greater level of comfort, believe it or not, when he's got a 1/4-inch steel propane tank in his trunk as opposed to a gasoline tank. Go to great lengths. The valves are all mounted, places they wouldn't be sheared off. Again, just things that you would think that you would do in an OEM environment. When we do a school bus, and we're doing one right now, in fact, we're doing one in the morning, we crash it, we put it all together, and then we just crash it. And we'll see what's happened as part of the safety standards you do for school buses. But in this particular case, we take a 4,000-pound sled, crash it directly into the tank at 40 miles an hour, and to date, maybe tomorrow will be different, but to date, we've never seen 1 cc of gas escape from that collision. And don't expect it tomorrow either, for that matter. To be successful, you got to match gasoline warranties. Everybody does it a little different way. And the good news is the GMs and the Fords of the world, they're realizing that they like the propane segment, and so they're making their engines work for propane. And with that, they bring the confidence that the OEM can provide the warranty. In cases where they don't, generally the suppliers go back in and provide a third party. I think the good news is if you're a fleet buyer and you have a wide range of vehicles, as most fleets do, most of those have some kind of application. I'll just talk for a minute. I've been talking so far about liquid systems. I'll just spend a minute. We represent IMCO, which frankly probably is one of the largest gaseous systems in the world. Pretty much the same technology. They add 1 engine control unit into their network. Again, they have almost the same injectors and fuel rail. Here, because we're bringing tank pressure up to the engine, we do put in a pressure regulator. And then, as any good system, we would put a filter in there somewhere to take the crud out right before it burns. Very simple system. Really, the only difference would be one bringing liquid straight to the cylinder and one bringing vapor. But other than that, in terms of performance, you hardly see a difference. And again, if you have questions about that, feel free to call to see us. We'll be here for the next 3 days. You can always look us up at CleanFUELusa.com or talk to Chris. Thank you.